Hi. In this video I want to show you a rework of a file from Thingiverse which didn't fit my needs to be reworked. What I'm going to do is the following. I want to download a part from Thingiverse. I want to duplicate this part and I want to add a shelf mounting hook to this part using part design. That's what we're gonna do, and that's how the part is gonna look when it is finally done. So this is the front side where the USB outlets will be, and that's the rear side, and in here that's where my bookshelf is going to be. So how did I do this? Let's first close. The first thing is I downloaded a file from Thingiverse. The file from Thingiverse I was downloading is a USB extension mount by Mr. Maker 192. Thanks for uploading this. And I did this rework with FreeCAD 0.18 in the preview version. From now on, I think it is quite good to make my videos based on 0.18. So you may ask, where do I get that from? Because if you look to the FreeCAD website, you will first see a version 17, which I've been using up to now. So we switch to there, and if you go to downloads on the website, you will find these versions which are still 0.17. But the time is ready now to use the development versions, and here you get the development versions. If you go to the FreeCAD releases page, you find all the previews. Installing the previews is straight ahead because the previews are, so to speak, portable versions, which means in the case of Windows you just choose which version you want to download, you extract it. You will need 7-zip or another program able to extract the 7-zip file. Just extract the whole thing to a folder like C/FC018 or something the like, and in the bin folder there you will find FreeCAD.exe. Just execute it. The similar is for OS X and for the versions for the plain Linux. Probably you may have a version of Linux that doesn't like this current version, so feel free to claim this in the forum if you don't have the possibility to run the preview version. There will mostly be a way to get that done. You can also have both the 17 and the 18 preview in one computer active. There's no problem. There's no real changes that hinder one of the versions to work with the same config files. You will share the configs. So back to FreeCAD. So as I said, I'm working with FreeCAD 0.18 and it is the version 15195 dated on the 13th of November 2018. Let's open the STL file which I have already downloaded from the internet. So this is the original file. Before we start to work on an STL file which we downloaded from Thingiverse, we should have a look at the file how it is done. Sometimes you may get a file that is not possible to rework because it's badly designed. If we look to this file, we can see there is a little step here, and that looks a bit like might be a problem, because sometimes the programs that people use for creating the STL files are not real capable CAD programs. They produce invalid STL code. Good. Let's see if that STL file is okay. We first open the mesh design workbench. That's what we need to do some analytics on that file. We go to meshes, analyze, evaluate and repair mesh. We click on repetitive repair. We choose the STL file we just opened and we click to analyze. So it's going to tell us it's got this and that faces and so on. It's got some self-intersections. Then we can click repair and it will repair those self-intersections. Actually, that is not a good idea for this design. We can leave it as it is. So we close this again and we open it once again. These self-intersections that we ignore don't make us any trouble. It would make us more trouble to have them repaired. So always be careful if an STL file needs repair, that sometimes it may get worse when it's repaired. And it may also make sense to use external programs like MeshMixer for STL repairs. They are especially made for the purpose of working with STL files, and that makes them work, sometimes makes them work better. Good. What else can we do? We can have a look at the STL file. If we go to the wireframe mode. Again, just for the purpose, here you can see there is something that looks a bit weird with these corners, and it also is a bit of a problem that these flanges are strangely mounted to the body. But anyway, they don't interest at all later on, and we can just ignore the errors. The next step we do is, again, we select the mesh, and there is another possibility, that is check solid mesh, and it tells the mesh USB extension mount is not a solid. Normally one would say, okay, forget it, take another STL file, because that one is not gonna work. Luckily that one will be working. So we can switch the workbench to part. We do a trial and error. The first step is always create a shape from the mesh. It tells us it wants a tolerance for sewing shapes. I always leave this to 0.10, and it did create a shape. So we can switch off the extension mount itself. We switch back to the as is display mode, and we see still looks to what we want. Now the next step that we have to do is we want to create. So before we convert this to a solid, we use the refine shape function. That gives us a shape that is a little bit different. If we look to the shape as it was before, this one, you can see we have triangles here as they were in the original STL file. Switching back, we need to go to the wireframe mode. We see we have those triangles here. Go back to the as is mode, switch that one off, switch this one on, still triangles, and the final one is not triangles, it's rectangular shapes. So this is easier to calculate with and gives us the possibility to convert this one to a solid. Now let's see if that works. Convert to solid. No error. It looks like it should probably work. We switch the shape version off and we have a solid that looks pretty well. The next step is you can delete everything you had before. We don't need this anymore. So let's save this. Shelf mount number 2. Good. So how do we proceed? There's two principal possibilities. One possibility would be to proceed in the part mode, where we can create cubes and subtract the cubes so we get those ears away and other things. But I leave those ears, they don't matter for me. What I'm doing is I'm switching to the part design mode now. So we switch the workbench to part design, and in the model tree we select our shape, or no, not our shape, our solid. And from this point we directly create a new body and make it active. So this creates a body with a base feature. A base feature is a fixed feature or a fixed solid to work on, which is created from the geometry found in this solid. You should not delete this solid, because if you delete it you will destroy your base feature. And it isn't a good idea to start like, okay, let's take this shape and start a sketch and go on. This is not a good idea, because you may get into trouble later if you work with sketches based on faces. Probably for the purpose here this may work, but you should never try to concentrate on using this mode. That's an old outdated mode that comes from 0.16, and starting with 0.17 the internal design of FreeCAD was changed, and we can now work with better tools than creating sketches on these shapes. Maybe later on it is something feasible again in a version 19 or version 0.20 when there's a solution implemented that copes with the so-called toponaming problem. Okay, so we are not going to work in a way that we create shapes, that we create sketches on these faces, or that we use the geometry from the feature itself. What we're going to do is we're going to create a bunch of shape binders, and we will work with these shape binders to create new sketches directly on the working plane. And as we speak of the working plane, let's first see how this was designed in 3D space, because there is something specific. If I switch on the origin and I move it a little bit, I can see that it is built on the XZ plane instead of the usual XY plane. So we have to cope with that our base working plane is the XZ plane. You can switch it off. Now let's start creating shape binders. What do we need? The first shape binder that we need is a shape binder that gives us this shape. We could probably think, oh, let's take both. No, this is not going to work because a shape binder needs a closed shape. So take this shape binder first. We create the shape binder with the default values and we name it left flange. So take the right flange, create another shape binder. Okay. Right flange. Then I want to have a shape binder of the front outlet. Oh no, this is not the front, this is the back. This is the rear outlet. Shape binder. Rear outlet. And another shape binder gives us the front outlet. So now we can switch the base feature invisible using the space key, and we see we have the outer geometry of our future block. So the next thing is I want to create a base block that is as large as the whole item. How do we do this? We create a sketch, and we create the sketch on the XZ plane. To be sure it completely fits into our block, I want to get some external geometry. Use the external geometry tool, and we select a couple of points on the circumference of these circles. We select this line and we select this line. That's enough, we don't need more. So we need some helping geometry. We toggle to help geometry and we will create a circle with 3 rim points. So we select point 1, 2, 3. Point 1, 2, 3. So now we have the circles. And what we now will do is we switch back to normal geometry mode. We select the rectangle and we put the rectangle briefly around the shape. So now we say this point shall be on this line. This point shall be on that line. This line shall be tangent to the circle, as well as the circle is tangent to this line. So now we have a defined rectangular shape which really covers the whole existing structure. So we close that, and what we want is we want to add. The next thing is I want to create a rectangular plate from this sketch by padding it. If I pad this 2 millimeters, that would work. But the problem is it should not be directing in this direction, it should point to the other direction. So if we do the following, if we now say okay, let's do it in reversed. Well, it doesn't. It's not showing us anything. If we want to have it symmetrical to plane, we can say okay, it's able to move down a bit, and if we make this bigger, it will still work. So the question is, why doesn't it work with just reversed? It doesn't do anything. So let's just leave it as it was. It points in the wrong direction. We will cope with the problem differently. The next step is, when you experimented with it, have a check on the sketch. Look if the sketch is still in a proper orientation. It may happen that the sketch loses orientation when you play with the pad in this specific configuration. Then you need to reorient the sketch to the exact plane. Then it'll work again. So what can we do to move our sketch downwards? Well, just let's play a bit and say okay, I want to have this minus 2 millimeters in Z direction. Apply. It moves, but it doesn't move to the right. Direction, it moves along. So that was the wrong direction. Let's try with minus 2 in Y direction. That doesn't work. Let's try minus 1. Apply. Still doesn't work, because now what happened is something went wrong. And we have to go back to all 0. Apply. Okay, and now the pad is valid again. And let's try playing in Y direction. And that works. So we must go in positive Y direction. Let's go to 2 millimeters and see. Oh, it doesn't work. It's 2 millimeters. Well, the reason is 2 millimeters would again break our shape from being solid. So let's take 1.999 millimeters and apply. And now we can see it mostly covers the shape, and my 3D printer is not gonna print 1 micrometer. And the 1 micrometer will also probably disappear when we convert to STL. But now the block is there where it ought to be. Time to save. File, save. So let's carry on. The next thing that I want to do is, from this block I want to subtract the inner structure. So that is pretty basic. We switch the pad off. We create a new sketch. We can still work on the same plane. And if I'm not sure 100% what's going to happen before constructing 2 hours and finding out, oops, that doesn't work, I usually just create a rectangular shape, close it, and just try to see what happens if I make a cutout. That doesn't work, obviously, because we gotta go into the opposite direction. It looks like something's weird. Now, the problem is, if we take the pocket again, make it reversed, and look to the inside, we can see it made the pocket, but strangely the pocket doesn't come through here. And that again has to do with the weird things that we have imported with our STL file. And there's a simple solution in this case, which is, sorry, I was going into the sketch instead of double clicking the pocket. I make this one symmetric to plane, and magically we now have a window where we can look through. So the thing that you should learn from this is, sometimes the kernel that is behind FreeCAD has strange habits, and sometimes you gotta think around the corner a little bit to find the easy solution. So as we now know it will work, we can switch it off. We can open our sketch and start with basic works. We need a couple of points from our existing geometry. I think that's all we need. And we will fix this to here. And now this worked. we'll fix this to here. Sorry, clicked wrong. This also works. We take another rectangle, put this in here, and we need some more external geometry. So fix this here. Fix that one there. And voila, we have a sketch. But if we now try to cut this sketch, we will get errors because that is not one shape. To make this one shape, there's a function trim an edge with respect of the picked position. Let's do. And now we have a shape that looks pretty good. Fully constrained. Switch on our pocket, and well, that's what I wanted. Next time to save. For my project I need two of these structures side by side and some other geometry which is going to be the hook for my whole 2 USB connector case on the shelf. Well, how do I do this? I select the body, and now we create a clone of the body. Nothing happens, seemingly, because the clone is in the same position as the original. So first let's go to transform and let's move it a little bit sideways using the arrows or the spheres. You can move your geometry. Each body can move on its own, as well as a part structure can also be moved. But be sure this is just a move which is calculated. The origin of the clone is still where it was created. There is a possibility if you really need to reorientate this. There's a couple of forum posts that cope with this problem and with different types of clones from other workbenches or from add-on modules that work a little bit different. But what I want to achieve is I want to put this, and I want to put it exactly here. We don't know if there is still a gap finally. So to be sure there is no gap, we move those two so they really fit. And to explain this furthermore, I moved them a little bit strange, so they are totally disorientated in the moment. To get these two shapes together side by side without any gap, we use the alignment function. We don't use any other workbench or any add-on module for this task. We just take the alignment tool. And we have to move them so they are visibly orientated, that we can see that both sides that have to be glued. And the main thing, or the main problem, is you have to select your glue points, so to speak, in the same sequence. Point 1, point 2, point 3. Point 1, point 2, point 3. Click to align, cross fingers, and that worked. The next step is I need a sort of a hinge to slip this onto my bookshelf. How do I do this? Well, first is I create a sketch that is a block sitting on here. We create a new body. I create another shape binder. Make sure I switch it off so I have the shape binder. Go into my sketch. Let's hide all the stuff we don't need. Take these two. Create a rectangle. And close. So this is now the rectangle which we're gonna pad, and the length that I want to have, that is 19 plus 3 millimeters. So this shows you can always, wherever you enter distances, you can always add calculations. So this is a big and mighty block, and we now want to have a cutout in this block so that finally we can slip it onto the bookshelf. As usual, we can probably go here and create the shape on the face, which we're not gonna do. And we still have that body. So how can we make this block move over here? Okay, we know this body is a clone from this body, and they have no gap in between. So why not go and create a linear pattern but the problem is, if we want to do it with a linear pattern, we must know the distance, but we don't know the distance. So we have to take another approach. Let's try it with a mirror feature. So that's what we want to mirror. And now we need to know where do we want to mirror. So we need a reference, and that is this face. Good, now we have the whole block. And finally, I want to make a cutout that represents the bookshelf. What we can do is we create a datum plane that goes perpendicular to our normal working plane and starts on the outer side of our original USB holder. To create the datum plane, we select this line. We can either select it from So to get a shape binder that lies flat on this face, we need this line that we derived from the original USB holder, and we create a datum plane. Now the datum plane is not as we need it. It is calculated against this line, but if we only have one line, it'll be normal to edge. So that is not really what I want. Let's try pitch. Well, 45 pitch brings us closer. So let's take 90 pitch. And we have the datum plane where it ought to be. On the datum plane, we can now create our sketch. As I usually do when creating sketches on new planes, I'm just dragging in a rectangle, and I want to see if that one, when I switch the pad on, creates a proper shape so it goes through all. That'll be all right. And now we switch off the datum plane. On this side, this is going to be the front, so we have to create the hook with an opening on this side. So let's go into our sketch, and we need some external geometry, but the external geometry is on a different plane. So we can only select this line from the previous sketch, and we say this point is coincident to that point. And before we proceed, I close and I look if that is creating the proper alignment. Yes, this is going to work. So now all we need is we define this as a height of 19 millimeters. And we create this distance from here with 3 millimeters. And we close it. We switch on the visibility. We have the clone. There we have the pocket, which we gotta have visible. And it looks well. So that is what I wanted to construct. Now finally we have 3 bodies. And we want to have one STL file that contains everything. So how do we do this? We switch to the mesh design workbench. We select all 3 items. We create mesh from shape, standard mode, and this gives us 3 meshes. We switch off our constructive geometry. We have everything we need, but as it is 3 individual pieces, we first have to combine them into one piece, and that is done with meshes merge. So we switch the 3 off and have 1 left over. Now let us export this one. Mesh 003, and let's see if that creates a valid STL. I open my favorite slicer, put this at a little bit of size, and add this mesh 003. And as we can see, it looks pretty well. Unfortunately, it has one non-manifold edge. It may happen that if you do this with a not so sophisticated slicer, you can run into trouble. This one is no problem, it just has an auto repair, and I let it repair, and now I can make a slice, go to preview, and it looks like it's gonna create something meaningful. So that was all. I've already printed it, and it is perfectly as I wanted it. So thanks for watching, and maybe next time we can go a little bit deeper into the tricky things of FreeCAD 0.18. Thanks for watching.